In this lecture, we are going to learn about another very important concept related to data types in JavaScript, and that is to understand what is value type and what is reference type. Now, value type and reference type is a very basic concept, but it is very difficult, or you can say it is a bit confusing for beginners to understand. So what I will try is I'll try to keep this lecture as simple as possible, and I'll explain value type and reference type in such a way that it will be easy for you to grasp this concept. So let's start. So in the very beginning of this course, we learned that in JavaScript we have 7 primitive data types. And these 7 primitive data types are number, string, boolean, undefined, big int, null, and symbol. So these 7 data types which you see here, these are primitive types. And apart from these 7 data types, any other value is of type object. So when you create an object, that object is of object type. The arrays which we learned about in one of the lectures of this course, the arrays are also object type. Basically, it is also an object in JavaScript. In the same way, functions are also object in JavaScript. And basically everything apart from the value belonging to these 7 data types are objects in JavaScript. So in simple terms, any data will belong either to these 7 data types. In that case, that data will be a primitive type, or it will belong to object type. In that case, it will be an object in JavaScript. So for example, number 30 belongs to number data type. So the value 30 is primitive type. But an array does not belong to any of these 7 data types, right? An array is not a number or a string or a boolean, etc. It is an array. So array belongs to object type. In the same way, when we create a function in JavaScript, that function also belongs to object type. So this is one way of classifying data in JavaScript. We can classify data as primitive type or object type. Another way in which we can classify data in JavaScript is value type and reference type. Now, a variable can either store a value directly, or it can store a reference to a memory address where the value is actually stored. And based on that, we can classify data as value type and reference type. So value type is that type which stores the value assigned to it. So when a type stores a value assigned to it, it is called as value type. And all primitive data types, a value belonging to a primitive data type is a value type in JavaScript. So number 30 belongs to number type, and number type is primitive data type. So number 30 is value type. A string value hello, it belongs to string data type. And again, string data type is a primitive type. And since it is a primitive type, the string hello will also be a value type. Now, when a type does not store a value directly, but it stores the memory address or reference of that value where it is actually stored, it is called as reference type. So every value which does not belong to a primitive type is reference type. So an array, it does not belong to any primitive data type. So an array is of type object, and objects are reference type. In the same way, a function does not belong to any primitive data type. So the function will be an object in JavaScript, and it will be a reference type. Now, what is the difference between value type and reference type? Here we learned what is a value type. A value type stores a value assigned to it directly, but a reference type stores a reference to the memory address where the value is actually stored. We are going to understand this value type and reference type with some examples, but for now just understand that in case of a value type, the value is stored directly in a variable. But in case of a reference type, variable does not store the value. It stores a reference, a memory address to the value where it is actually stored. Now, when we create a variable in JavaScript, the value assigned to that variable is stored somewhere in the memory. And we can classify memory into two types: stack memory and heap memory. Now, another very important point to understand here is that the value of value type or primitive type, it will be stored and executed in stack memory. So a number value or a string value or a boolean value, these will be stored in stack memory, and there they will be executed. But the value of reference type, like objects, functions, arrays. These are stored and executed in heap memory. So any object which you create in JavaScript, it will not be stored in stack memory. It will be stored in heap memory. So any value of reference type, it will be stored in heap memory. And any value of primitive type, it will be stored in stack memory. This is another important point to remember. And one more thing which you need to remember is that when we create a variable or a function, we give a name to that variable or to that function, right? So for example, when we create a variable x, x is the name for the variable which is going to store a value. In the same way, when we create a function, let's say greet, greet is the name of the function which is going to store that function definition. So these variable names are also called as an identifier. And an identifier will always store a value from stack memory. Remember this point very carefully. An identifier will always point to a memory address in stack memory. Keeping all these points in mind, let's now try to understand value type and reference type with an example. And to understand it, what I'm going to do is I'm going to create a variable x and assign it with the value 30. And now let me create a variable y. And to this, I'm going to assign x. Now here to this variable x, we are assigning this value 30. 30 is of number type and number data type is a primitive data type. And we have learned that all primitive data types are value types. That simply means that this variable x is directly going to store this value 30. And when we are assigning the x to this y, the value stored in this variable x will be copied to this variable y. Now what value is stored in this variable x? It is storing 30. So 30 will be copied to this variable y. Okay. So if I go ahead and if I log x and y, and if I save the changes, you will see 30 and 30 is logged here because both x and y are storing this value 30. And if I go ahead and if I change the value of x to let's say 100, and after that if I log x and y, you will see that for x it is logging 100 and for y it is logging 30. So changing the value of x has not changed the value stored in this variable y. Okay, that's because in case of value type, the value is what gets copied from one variable to another variable. And later, if we change the value of a variable, it is not going to affect the value of another variable which copied the value from that variable. Let's try to understand it with diagrams. So here we have the same code which we saw in VS Code. And here you will also see that we have two memories. We have stack memory where the value type is stored, and we have the heap memory where the reference type is stored. So here we are going to understand how these variables will be created and it will be stored in the memory. So at the first line, we are creating a variable x and we are assigning it with the value 30. So this value 30, since it is of number type and number types are primitive type and primitive types are value types and value types are stored in stack memory, right? So this number 30 will be stored somewhere in this stack memory, and an identifier with this x will be created because we are calling this variable as x. So an identifier with that name will be created which will point to that memory address where that value 30 is stored in the stack memory. So here for this identifier, if you notice, the value is 30. This 30 value is stored at this memory address and this x is pointing to that memory address. So the value for this x is this value 30. Then what we are doing is we are creating another variable y, and to that we are assigning the value stored in the variable x. Now what is the value stored in the variable x? It is 30. So here what will happen is another identifier called y will be created, and since we are copying the value of x to this variable y, this y will also point to the same memory address where that value 30 is stored. And that's why when we log x and y, both of them are going to log the same value 30. All right. Now later what we are doing is we are changing the value of this variable x to 50. So again, this 50 is a number type, it is a primitive type. So this value will also get stored somewhere in the stack memory, right? And now this variable x, now instead of pointing to this value 30, now it is going to point to this memory address where that 50 value is stored. Okay. And now when we will log x and y, x will log 50 and y will log 30. Now, what will happen if I also change the value of y? So now I'm changing the value of y to 100. So this 100, since it is a primitive type, again it will be stored in stack memory. So somewhere in this stack memory, this value 100 will be created and stored. And now this identifier y, now instead of pointing to this value 30, now it is going to point to this value 100. And remember that in memory, the values are immutable. So when we are changing the value of y from 30 to 100, this 30 value did not get changed to 100. This 30 will still remain 30, but this value 100 will be stored somewhere in a new memory. And this variable y will point to that new memory address. So this value has not changed. Instead, the new value which we are assigning to y, that gets created newly in the memory address. And the reason for that is, in memory, the values are immutable. You cannot change those values. Now, some of you might ask, okay, so we have this value 30 stored in the memory, in the stack memory, but this value is now not referenced by any identifier. So what will happen to this value when it will get removed from the memory? Well, this value 30, which is not being referenced by any identifier, it will be removed at some point from the memory. But when it will get removed, that we will talk about in great detail in our next section. Okay, so this is value type. And if you notice here, in case of value type, the identifiers, the variables, they directly store the value. They're pointing to some memory address, but at that memory address, we are storing a value. So we can say that the identifiers, the variables, directly store the value. And when we copy value from one variable to another variable, the value is what gets copied from one variable to another variable and not its memory address. All right. Now let's talk about reference types. So let me go ahead and let me comment this code here. And now let's go ahead and let's create an object. I'll call it as obj1. And to create an object, we use a set of curly braces, and inside that we specify some properties. So let me specify a property name here, and let's say name is John, and let's specify another property called age, and let's say age is 28. Okay. Now here we are creating an object, and object is reference type. Here we should not use semicolon. So objects are reference type. Now let me go ahead and let me create another object obj2, and to this I will assign obj1. Okay. Now if I go ahead and if I say obj2 dot age equals 30. So here we are trying to change the age property of obj2. Now let's go ahead and let's log obj1 and obj2. If I save the changes, you will notice that when we are logging obj1 and obj2, two objects are logged, obj1 and obj2. But here if you notice, for the obj1, we have age as 28. But here we can see the age as 30. We change the age property of obj2 to 30. So for obj2, the age is 30, that is fine. But for obj1 also, the age has changed to 30. Now why is that? That's because when we copy value from obj1 to obj2, or in more broader terms, when we copy value from one reference type to another reference type, it does not actually copy the value. It copies a reference, a memory address where that value is stored. So in this example, we are not copying this object from this obj1 to obj2. Instead, this object will be created somewhere in the heap memory. And we are copying the memory address of that heap memory from here to obj2. Let's try to understand it diagrammatically again. So again, here we have the same example which we saw in VS Code. We are creating this variable obj1. So obj1 will be the identifier name, and to that we are assigning an object. Now objects are of reference type, and where does reference type get stored? It gets stored in the heap memory. So this object, it will be created somewhere in the heap memory. Let's say this object is created at this heap memory address. Now this identifier, if you remember, we learned that the identifier will always point to a memory address in the stack memory. So here for this obj1, an identifier will be created. It will point to a memory address in the stack memory, and at that memory address, instead of storing a value, instead of storing this object, it is going to store the memory address of the heap memory where that object is actually stored. So the value for this obj1, if you notice, is a memory address. And which memory address? It is the memory address of this heap memory where that object is created. So since objects are of reference type, they do not store the value directly. Instead, they store a reference, a memory address of the value where it is actually stored. I hope this point is clear. So for a reference type, we are storing a memory address. Now, when we are creating this obj2, again an identifier called obj2 will be created. And what are we assigning to this obj2? We are assigning the value stored in this obj1 to obj2. Now, what value is stored in obj1? It is storing a memory address, a reference to a heap memory. So this value here, this memory address will be copied from obj1 to obj2, and both of them will point to same memory address. So both obj1 and obj2 has the same value, which is this memory address. And at this memory address, we have this object created. Now, when we are changing the age property of obj2 to 30, this obj2, it is indirectly pointing to this object. So this obj2 is storing this memory address, this reference, and at that reference, we have this object where we also have the age property. So when we are saying obj2 dot age equal to 30, it is going to change the age property here and its value to 30, right? The value has changed to 30. And since obj1 is also pointing to the same object, when we are logging obj1, there also the value has changed to 30. So we changed age property on this obj2, but both obj1 and obj2 are pointing to the same object using this reference. The change will reflect in obj1 also. And that's why when we logged obj1 and obj2, in both places, the age was changed to 30. Now what will happen if I assign a new object to this obj2? In that case, again, this new object will be created somewhere in the heap memory because objects are reference types and reference type values will be stored in heap memory. And since it is stored in heap memory, a reference, so this value is stored at this memory address in the heap memory. So what will happen is in the stack memory also, this reference will be stored. Okay, so this reference is stored in the stack memory at this memory address. And now obj2 will point to that memory address. So now this obj2 is storing another reference. It is not storing any value directly. It is storing a reference to a heap memory address. And that's why we call objects as reference type because they store a reference. So now I hope you understand what is a reference type and why we call it as reference type. Now let's take one more example. So what I want is I want to set the obj1 to null. Now when I set obj1 to null, that means now this obj1 will not point to any memory address because by setting it to null, we are simply saying that for this obj1 we don't have any value. So that means this reference will be removed. Obj1 is now not pointing to any memory address in the stack memory also, but this object, it is still there in the heap memory. But this object, since it does not have any reference in the stack memory, at some point of time, browser is going to run a garbage collector, which will remove all those objects which is not being referenced from anywhere in the stack memory. So this is one such example. This object here, it is not being referenced from anywhere in the stack memory. So when the browser will run the garbage collector, it is going to remove this object from the memory and it is going to free up this memory address. Now we will again talk about garbage collectors in great detail in this course. But for now, this is all you need to understand. Okay. So as we learned earlier, a variable can either store a value directly or it can store a reference to a memory address where the value is actually stored. And based on that, we can classify data as value type and reference type. In case of value type, we can say that the value is stored directly in the variable. But in case of a reference type, a variable does not store a value. It stores a reference, a memory address to the value where it is actually stored. And we also learned that all primitive data types in JavaScript are value types. So a number is a value type, a string is a value type, Boolean is a value type, big int, symbol, these are all value types. But apart from these primitive 7 data types, any value like array, function, objects, they are all reference types. And it's very important for you to understand how the value type and reference type works, because if you don't understand that, you might introduce bugs in your JavaScript program. So in the next lecture, we will see a couple of examples where we will learn why we need to understand value type and reference type when implementing some functionality.